All right, welcome. We're going to look at our first test review for your midterm coming up next class. What you need to do first, I'm going to pause the video, but here what you need to do. You need to open up your digital classroom. Click on classwork and open up the Desmos AP Pre-Calculus version. I want you to have that one open. That's what we're going to be using today. Once you come back online, I want you to graph this equation. I'm going to go ahead and graph it, then I'm going to pause and give you a minute to catch up to me. But that's what we're doing right now. And then we will pick back up. Type that equation in. All right, as we get started here, the first problem says the charge C of a cell phone is given by this function where this is true about the T. How many extrema does this function C have on its domain? Additionally, label any extrema as either global, local, or both global and local. What I need to remind you of on this first review problem is how to do a restriction or a constraint, whatever you want to call it, on Desmos. Does anybody remember what to do? We did this on lesson 1-4. Here we go.
Put that little symbol.
You put the squiggly brackets around it. So go ahead on your packet. So if you look back at this, you'll know how you did it. You put those little squiggly brackets just around like that. And that's what we're going to be using here in Desmos. So I'm going to put right after the 100, I'm going to put that squiggly bracket 0 less than, it's not typing. What's going on? 0 less than equal button T less than equals 6.63. My graph right now, I'm extending off the screen. I need to zoom out a little bit so I can see my graph. There's my graph. Probably zoomed out too far. That's the graph we're working with right there. How many extrema do you see on this graph now? I'm going to make sure you can see what I have typed in. How many extrema do you see on this graph? What is an extrema? A maximum or a minimum. You look for where you change direction or a starting and ending point of a graph. This graph has two. It has this, what would this point be? A maximum or a minimum? A maximum and that minimum. Now we're going to draw that over. All right, so I'm going to take this graph over and I'll draw it over here just to make it easier for myself. I'm going to make it not quite so narrow. So it seemed like it went something like that. I could make it a little bit closer. Maybe it starts a little bit more steep and then it cuts down. But either way, make sure you have that on your packet, that it kind of comes in like this, and then it went around and dropped like that. The coordinates here, we had 0, 100. And my other coordinate I lost. What was my other coordinate down here? We need 3 decimals. In AP Pre-Cal, you're always required to take 3 decimals. If your number is bigger than that, you don't have to round. You can truncate. That just means cut it off. So I'm going to have 6.629, 0. 6.629, 6.629, 0. So there's my graph. It says how many extrema does the function C have on its domain? How many extrema? 2 extrema. We have 2 extrema. Extrema means maximums and minimums. Additionally, label any extrema as either global, local, or both global and local. What is this here? What would you call that point right there? Maximum. Is that the highest point on the entire graph? So it's a global. So every maximum is always, and minimum, it's always local. It's just whether or not it's also global. You could also use relative and absolute terminology as well. This right here is a global and local maximum. This point down here, is that a global or just a local minimum? Global. So we would say this is a global and local minimum. All using the words I use that one lesson. All extrema are always relative, just the same, they're always locals, but they're not always absolutes or globals. Global and absolute mean the same thing. Okay, so global means the same thing as absolute. That's what that means. It's like absolute. Whereas local means relative. All are always relatives. They're always locals, but they're not always absolutes. In this case, they both work. Questions over how to graph with constraints, with restrictions. Any questions over that? Okay, let's move on to our next problem then.